This section demonstrates aspects of both loose and dense connective tissues after conventional staining with hematoxylin and eosin. This large circular structure is a section through the subclavian artery. It also contains a variety of surrounding structures, all embedded in connective tissue. In particular, these clusters of pink structures are sections of nerve bundles or nerve fascicles. A knowledge of anatomy would probably suggest these are profiles of a section through the inferior trunk of the brachial plexus. Although the inner part of the arterial wall is made up of smooth muscle, its outer half, its adventitial layer, is composed of dense and somewhat regularly arranged connective tissue. And now notice a sudden transition to very loose surrounding connective tissue. In both areas, the pink coloured fibres you can see is collagen. The major nerve bundles cut transversely are also wrapped in sheaths of dense connective tissue. Nerves need a substantial blood supply, so a plexus of relatively small blood vessels accompanies them. These include capillaries. Here, as usual, the blood vessels, these circular profiles here, and again over here, run in connective tissue. They're truly connective tissue components. Turning to dense connective tissues, a good example of an irregular arrangement is the dermis of skin. It's a very tough layer, resisting injury under many circumstances. For now, look in this image only at the dark red masses of collagen here in the dermis of thick skin. This is a section through your fingertip. Ignore the epidermis, which is in this region along here. In fact, let's look at a higher magnification of the dermis. Dense connective tissue here is characterized by both the great amount of collagen and by the size of the collagen strands. The collagen in loose connective tissue is mainly in the form of individual fibers, about 1 micrometer in diameter. Dense connective tissue has large bundles of collagen fibers. The denser a connective tissue is, the grosser its bundles of collagen fibers are, as you can see here. It's evident that the bundles of collagenous fibers in the dermis can be massive in size. They run in many different directions. Some are cut transversely. Some run in the plane of the section for appreciable distance, but most are cut obliquely. So we would further classify this as dense, irregular connective tissue. This is actually very important in the dermis of skin, as it can then dissipate the shear and compressive stresses on skin in many directions and so absorb this stress. Note the gaps between most of the collagen bundles. They fortuitously allow you to identify individual bundles easily, even though most of this empty space is artifactual. It formed because the collagen bundles shrink during dehydration of the tissue. In life, these gaps were small and filled with a now leaked out gel of ground substance. So, use the size of the collagen bundles to distinguish dense from loose connective tissue instead of the spaces that may be present. In fact, loose connective tissue often shows less shrinkage artifact because the larger number of interlaced fibers forms a feltwork that shrinks as a whole instead of allowing individual bundles of fibers to pull away from each other to form internal gaps. This is a little bit of loose connective tissue and smaller collagen fibers in the connective tissue region directly under the epidermis. This is the papillary layer of the dermis, and I'll describe this layer in more detail in my lecture on the integumentary system or skin.